students, welcome back to the another session of our data structure journey. Today we are going to learn double-ended queue and we are going to implement in the C language. So first we have to know what is a double-ended queue. By the name double end means both the end we can able to use. Generally, whenever you go for queue, that is the linear queue. Linear queue is a one type of data structure where insertion is done from one end and deletion is done from the another end. Means one end is specific for the insertion operation, another end is also specific use for the deletion. But double-ended queue is a linear data structure where insertion and deletion can be possible by the both the end. That's why it is called as the double-ended. Both the side we can perform insertion as well as the deletion. We can say it is a generalized version of the queue. Then it does not follow the fast come fast serve, because whenever we go for the queue, what happened, the element inserted in fast is going to be delete fast, but here what happened, insertion and deletion can be performed both the end. So this is a queue, this is the rear end, this is the front end. Rear end we are used for insertion and front end we are used for the deletion. But in case of double end, both the end we can perform insertion operation as well as the deletion operation. That's why it does not follow fast come fast out. Next one is the types of double-ended queue. So double-ended queue means both the end. Now what are the category? Category is two types. First one is the input restriction. Here input is restricted, means both the end cannot use for the insertion operation. Only one end can be used for the insertion operation. Output means that restriction is put in the output, means only one end it can be possible the output, means deletion both the end cannot possible to perform the. So input restricted, in this case insertion operation can be performed from one end, whereas the deletion performs on both the ends. So now this is the, here the deletion can be performed this end, from the rear end can be possible, from front end can be possible, but insertion can be possible from one end. That's why it is called as the input restricted queue. Then output restricted, in this case, the deletion operation can be performed from one end, whereas the insertion operation can be performed the both end. So output is restricted, deletion is restricted. So deletion is done from this end, as but insertion can be performed both the end, means front end and rear end. That's why it is called as the output restricted. So what are the various operations we can perform by the double-ended or DQ? Generally, double-ended queue we called as the DQ. First one is the insert operation at front end, insert from the at the rear end, deletion at the front end, deletion at the rear. Both then we can, so both then the deletion operation. Then get the front item from the queue. Means what is the front item or what is the rear item? It can be possible. Then check whether the DQ is full or not. Check whether the DQ is empty or not. So is empty, is full. Another operation we can perform, that is the pick operation. Pick operation, here what happened? We can get the front as well as the rear. So these two operation is for individual front item, individual rear item. But if you go for pick operation, then it will retrieve both the get as well as the get the front information as well as the rear operation. Let us implement the our double-ended key using array. So this is the program, we have to use the array. So now we are already included the header file. Now we have to need a array. For example, array, I make the name as a Q and we initialize value is the 10. But it is, we are designing a program where the each and every time whenever we run the program, at that time it will ask how many elements you want to store into the queues. According to that, the overflow condition will be decided. So we just make the max size is going to be stored whatever the end user enter the value. Initialization, there are two pointer is required. First one is the front, second one is the rear. So rear pointer is initialization -1, front pointer is -1. So for this program implementation, it is recommended that you should know the how to perform the array operation, as well as the minimum thing is we require that the circular queue, because here we are implementing both the side as well as the, it is the very much similar to the circular queue. In my description section, I put the link for the circular queue using the array. So if you cover this portion, then it will be easy. Or anyhow, I will explain all the things in this video. No no that much big issue, but if you know, it is good. So we make the front equal to -1, then we make the rear equal to -1. Front is points to the where we are going to the delete, and here is the insertion. But here both the send we can go. So first we have to check for that our queue is full or not. For that, if it is full, it returns the value 1, otherwise it returns value 0. So integer, so function name is full. Function does not take any value, but return is integer. So what is the overflow condition? If front equal to 0 from starting elements 2 and front equal to max size -1. This is the first condition. Second condition is, because it is a, we are implementing by help of the circular queue, because both the end we can use. So that's why if the front equal to front -1, if both the condition is true, then only we can say this is our queue is full. So this condition is overflow. Then only we have to return value is true. So if this condition is true, then return 1, else return 0. This is the condition for the next one is next function we have to think whether our queue is empty or not. So is empty. If it is empty, then it returns value is 1, otherwise returns value is false, 0. So if front equal to -1, then return 1, else return 0. Open 0. So our is empty, is full, is over. Then we have to go to define that. There are 4 functions this we have to write down. That is a insert for, insert front, insert rear, delete front, delete rear. So first we have to go for the insert front. So void insert. So this function is used to insert from the front side. So from front end. So here first we have to check whether space is there or not. If space is there, then only we can go for insertion. So if is full is true, then what we have to write down? Printf q is overflow. So if overflow means we cannot insert the data, else means it is not overflow. Then we have to ask the end user to enter the data. Then we have to write down printf please enter the data into, so whatever we enter we have to store in a variable, that is scanf. By help of scanf %d, which variable, for example variable is n. So we have to declare that n is a integer data type, so integer n. Once we declare the variable and we store the value, then we have to think which location we have to insert. If our queue is empty, means we have to make the front as well as the rear to the 0 index, then only we can store. So how to check our queue is empty? If front equal to -1 and rear equal to -1. If both the condition is true, means our queue is empty. Queue is empty. If queue is empty, then what we have to make? We have to make the front equal to rear equal to 0. Then we have to store at the front end, because here insertion from the front. So we make the queue front equal to n, means whatever data we enter, we store inside the n. So we have to store in. So this is the case whenever queue is empty. Then next case we have to check if front is 0 means front right now is 0 index. Then what happened? We have to insert from the front side. So if the front is 0 means we have to go to the end of the queue. So that's why we have to make if front equal to 0, then front is point to first index. So we need to move last of array location. So what we have to do? If it is 0, then what we have to make? We have to make that is front equal to max size minus 1, then q front equal to n. Store the value. Otherwise, what happened? We have to simple store inside the front. So whenever we insert into the front means what happened? It will how to do it? Because it is indexing from the ascending order, so we have to make the minus. So front equal to front minus 1, we have to decrease the front value. Then we have to insert the value into the fronted. Front equal to n. So our insert into the first position is over. So next function we have to define how to insert the data from the rear end. So the function name we make as a insert rear. Here the first function does not take any parameter, also does not return any value. As I have already told that I prefer always to make function as simple as possible. Is full. First we have to check whether space is there or not. If space is there, then only we can insert. So for that we are going to check the is full. If it is true, then what happened? We have to write down Q is overflow. So insertion cannot possible. Else. So next one is the else means we have to ask the user to enter the data into the queue. So printf new line, please enter the data into the queue. Then we have to scanf it. Once we read, then we have to check whether queue is empty or not. If the queue is empty, then we have to make the front as well as the rear equal to 0 and we have to insert the value. So to check the queue is empty, so we have to make the condition if the front equal to -1 as well as the rear equal to -1 means queue is empty. If queue is empty, then what we have to do? We have to make the front equal to rear equal to 0. We have to initialize to the first index of the queue. Then we have to write down front rear equal to the data, that is the n. So insertion for the empty queue is over. Then we have to check else. Whether rear already reached the maximum size. So else if rear equal to max size -1. Why -1? Because indexing starting from 0 to max size. -1. Then what we have to do? Then we have to make the rear to, if rear already reached the maximum size, as we have to do both the way we are can able to insert, that's why we make the rear to the first position of the queue index equal to 0. Then we have to go for q rear equal to n. So insertion is this part is over. Otherwise normal insertion means We have to increase the rear pointer by one value. Then we have to store the data. Very simple. This is a simple case. Normal insertion. So insertion at the rear position is over. Then we have to go for deletion. So deletion in this program, we combinedly implement the input restricted as well as the output restricted queue. So that's why we have to write down the both delete from as well as the delete from the rear side. So delete. So now we are going to write a function to delete the data from the front of the queue. So anyhow, whenever we go for delete, we have to check whether our queue is empty or not. If empty, there is no data, so there is nothing to retrieve or delete. Printf new line, queue is under flow. Then else means data is present inside the queue. Then we have to first print the data present inside the front end. So we have to printf printf new line %d then we have to after deletion now we have to think which location next the front point or position should be point so that it can be point to the next element to be deleted. So for that we have to check whether front is equal to rear. Why this condition is used for which condition? Whether the list is if the front equal to rear means the single element present inside the queue or this is the last element. So this is the last element inside queue. If this is a last element inside the queue, then what we have to do? We have to make the front equal to rear equal to -1 because there is no element. So this is the condition for the empty queue. Then else if next condition we have to check whether front already reached the maximum size end of the queue, that is max size -1. If it is already reached the end of the queue, then what we have to do? We have to make the front to the first node, first position. So we have to make the front equal to 0. Else means this is the normal case. So normal means just we have to increase the front by one value. Simple. This is the very easy case. So this is the further deletion from the front end. Next one, we have to write down delete from the rear position means from the rear position we want to delete the data from a double-ended queue because both the end we can able to delete the values. So here also same thing we have to check if is empty whether queue is empty or not. If the queue is empty means there is nothing to delete. So we have to write down printf new line queue is underflow condition. So if it is an underflow condition, we cannot delete any value else. Means the queue have some element. If the queue have element, so first we have to print the which element is going to be deleted from the rear side because it is a deletion from the rear position. So %d then what we have to make? Once deletion is done, then we have to check. Okay, this is the queue rear. We have to write down this because from this only we deletion. Once the deletion is over, then we have to adjust the rear pointer. So same thing if front equal to rear means last element of the list. Last element inside queue. If it is a last element inside the queue, then what we have to do? We have to make the front equal to rear equal to -1 because this is the condition for the empty queue. Once we deleted the last element present inside the queue, then we have to make the from front as well as the rear as a -1. So it becomes to be It comes to the empty queue. Then else if rear points to the first node, first index, then what we have to make? We have to make the rear to the last of the last of the queue. So we have to make the max size minus 1. Else. Else means this is a normal deletion. So we make the rear minus minus. Because deletion, we have to decrease the index value. So this is our deletion is over. Next, we have to write down the display function. So void display. So here, if you go for display, so first we have to check the data is present or not. If it is empty is true, then what it will be happen? It will print the queue is empty. Queue is empty. Else means data is present. So if the data is present, we can print. So just we have to write down printf new line. This is our EQ elements are now we have to check if the front is less than rear value or not. If the rear value is greater than the front means we can print direct like a linear queue. We can print the value. So simple we have to check if rear is greater than front. So it's very simple. Means we have to print the value from the front to rear. This is a linear print, so we can go write down for I equal to front, I less than. We have to print up to that rear value. So rear I plus plus. We have to print. Then what we have to print? We have to print printf pers percent d. Which value we have to print? We have to print the I value. Then we have to also declare I is a integer. So we have to declare integer I. Okay. So if it is rear is greater than the front, then we can print the data as a linear queue. Else means data is in a circular format. So what we have to do? We have to print the value from front to the maximum size, then 0 to the rear size. So here what we have to make the for I equal to front, I less than equal to max size minus 1, then I plus plus. What we have to print? We have to print the same UI we have to print. So I just copy paste. Then, so whenever we print after one value, we need one tab space. Otherwise, it is difficult to distinguish between the data. For this one, then what we have to make? We have to print the same value for front equal to which location? Front equal to I equal to 0 to rear position. So we make the I equal to 0 to rear. Then we have to print the value. So this is our display function is completed. Once the display function is completed, the display function is same as the circular queue display. I have already explained in all the details of this display in the circular queue video. I always also put that in the description section. You can refer it. So right now, next one is the main function. So in this function, what in this program we are going to do? We are going to do that is the input restricted queue as well as the output restricted queue. Here case one is for the input restricted, Then case 2 is for the output restricted. If you go for input restricted, then what happened? Input means insert it one position, delete on position. That's why case is 3. So here we are going for three cases. Case 1 is for insert for, case 2 for the delete for, case 3 for the delete rear. So according to that we have to, so here we have to go for two switch cases. One switch case for the input restricted, output restricted. After that, another switch case we require for insert front, insert rear, delete rear. For this portion we are going to do. So anyhow we require two switch case. For switch case we require the choice. So for one switch case I make the variable choice. Another switch case I make as a option. So we can write down integer choice is a one variable or option another variable. Then we have to write down printf. This is only for output screen. This is we can write down deque implementation using array. After that, the semicolon. Then we have to ask the user what is the size of queue. So please, the user has to write down, please enter the size of queue. Maximum it can store the 100, but each and every program we ask the user enter the size percentage. Then which is the size we have to store in the max size, because we are already make the max size as a global variable, so it can read the value from anywhere. Once the spec, then what happened, we have to go for do. So here do while cases, for the case 1 is for the input restricted, case 2 for output restricted. So we have to write down printf new line 1 for is the, so input uh, restricted deque. Then 2 for output restricted deque. So depend upon the value enter, according to that the switch case will be executed. So scan %d. So here I store, we read the value by of the choice. Then case 1. Sorry. Then we have to put the switch case. Switch case choice. If case 1 means it is a input restricted. If it is a input restricted means here again it will ask us whether you want to go for insert front or insert delete or insert rear. So here we have to write down do while once again. So do make this case here. Here if you go for case do, then what happened, do means then we ask the user printf new line 1 for what? 1 for insert at rear position, because it is a input restricted. Then 2 for delete from front end. Then 3 is delete from the rear end. Then 4 for display. Then new line. Then one new line will be created. After that, the semicolon. So whatever it will read, then we have to scanf percent %d. So here we store in the value that is the option. So option is the variable here we are using for to read the whatever we enter from the keyboard. So this is our option. So here option we have to put into the switch case. Switch option. So depend upon the option, case will be executed. Case one. Here it is insert at rear position. So here what happened? Insert rear function will be called, then break, then case 2, then delete from front. So then delete front, then case 4, that is display. Default printf invalid option. So this is our switch case is over. Then we have to go for do while. How many options? 4 options. So here we have to write down while options not equal to 5. It will execute until that. Then this is for our case 1. Once it is done, then we have to go for break. This is for case 1. Then we have to go to case 2. Case 2. If I make the letter size small, then it will be visible to clearly. Let me see. So this is our case 1 is over. Now we have to go to the case 2. So case 2, here in case 2, what happened? We have to again go for do while. Reason is that here also for the case 2 means what? Case 2 is for the output restricted DQ. For output restricted, we have to go for output is restricted means deletion is one, insertion from front end as well as the rear is can be possible. So that's why we have to write down if do, then what happened here? Then we have to write down printf new line. So here first option is insert from front. So case 1 we make the insert from front. Then case 2. Case 2 is delete from front end. So here also we can write on front end. Then Case 3 is that is delete. No, here it is a input restricted, only one side insert deletion can possible. So we make insert at rear end. So here insert at front end, so rear end is then after that fourth is for display. Display. Then new line should be created. After that the semicolon. Then what happened? This is for this one. Then we have, then whatever we enter, we have to scanf. Scanf %d, which value we have to store? It will be stored inside the option. So actually now letter size is small, but to visualize we have to need the small size, otherwise there is a chances of wrong typing. So then we have to put into the option case. So we put into the option switch case 1. Case 1 we have to write down insert front. Then we have to go for break. Then case 2. Then delete front. Then break. The same sequence we have to follow as per we are enter here. Otherwise, no syntax error, but whenever we run the program, we face the problem. So insert at rear. Then we have to break. Then case 4. Case 4 is for display. Then break. And this is the do is over. So here while choice is not equal to 5, so this is case is over. Then here the switch case is over. Here this is the do. No, this is for option. This file is for option we are going to know. So this is for I make small letter still, because here we put the switch case for the option. No? That's why we have to go for option is not equal to 5. Then so this is for our case 1 is over for choice for input restricted. Case 2 for is output restricted. Then after that we have to go for break. Here the break for case 2. Then case 3, that is for here we make the case 3 for exit or not. 1, 2 only. So it is no, there is no case 3, only default. So this is for default. That is what is the default? Default is printf new line invalid choice. Then we have to break. Here also we are not write down the default for the for this one we are not write down the default. So let us write down default print invalid option. Once. Then we have to write down the break. Let us check while switch case break, then the break, then default break while. So this is the end of. Okay, this is the switch case printf, then this is the break is over, then this is the switch case is over, then this is one is the while, do while, then while choice is not equal to 3. It is over. Let us compile the program. Hope we are able to get the result. Compile and run. Okay, okay. Yeah. Display was not declared for display. What is the function name? Sorry, we write down correct spelling mistake. Okay, then while option was not declared. Okay, here option is declared, not options. Yeah. So let us please enter the size. For example, I enter the size is 5. Whether input restricted or output restricted. Input. So insert at rear. 20, then 30. We have to make the tab space, otherwise it's same tab. But anyway, let us run the program. We are getting result or not. Let us, we have to check the program because when we run the program, we found that we entered the size 5, but after 5, it took the elements. So why it happened? Okay, okay. This condition, it should be our operator. Both the case can never be possible. Okay, okay. If front equal to 0 and front equal to maximum minus, or it is, sorry, I entered the AND operators. Sorry. Let us run once again. Size is 5, input restricted. So we have to enter the value 10, then 20, then 30. Taking the elements. Why? Because size we are already mentioned 5, but okay, let delete is working or not. So let us go for display. Display is front end 60. I did the correction because this line we did so many wrong things. This operator I make as a AND operator. Here also I make the front equal to max size. No. This is the actual correct answer. I don't know how I did such a big mistake, but anyway, right now I rectify this one, and if we run the program, okay, for example, I enter the size. Now input restricted means only one side we can able to insert. That's why insert at rear, front end deletion. So now I go for insertion 10, then 20, then 30, then 40, then 50, then overflow. So it takes the only 5 element. After that, immediately we will got the error message. So now this is the data 10, 20, 30, 40, 50. Because we are done for insertion from the rear end. Now I have to delete from the front end. So which element is deleted? Front end is the 10. Now if I go for display, then 10 is already deleted. That's why initial the data 10, 20, 30, 40, 50. So we go for delete from the front end. So front end means this one is the front end element. So 10 is deleted. After that, we go for the display 10, 20, 30, 40. If because it is a double-ended queue, both the end we can able to delete. Right now, we have to go delete for the rear end. Rear end, if I go for 3, then 50 is deleted. So this side is deleted. If I go for display, 20, 30, 40. 20, 30, 40 because this side is already deleted. If again I go for deletion, front end it will be display which element. Current right now the queue is 20, 30, so 20 is deleted. So we concluded that this one is correct for the input restricted table. Next we have to run for the output restricted. For example, I enter the size is 40. Now we have to go for output restricted means only one end we can able to insert. Here the one end is front end. So we can insert from any end. So I enter the 10, then 20, then I go for display. Because we are go for the insert front end. So initially 10 we insert, after that front we enter for 20. Now I go for 3. Means insert from rear end 30. Again I go for 40. Again I go for 50. Again I go for overflow. Already we are entered. Now if I go for display, so it will display the element 10, 20, 30. So according to the data is displayed. So now if I go for delete, so which element? Front end is deleted, then go for deletion, 10 is deleted. If I go for display, so right now only two element is present, that is the 30 and 40. So this is the way we can able to do the double-ended queue, either input restricted or output restricted. And in my PPT slide, I will upload all the updated program because initially we did some mistake. So final program I will update in the PPT. Don't worry. Already execute the program right now. We are already got the correct answer. So what are the basic operation we have to perform by the DQ? So these are the operation we can perform. I have already completed the front and inserting the front end, rear, deletion front, deletion rear. So this is the basic operation. So remaining operation we can perform that one by one, a simple function, and we have to call in the menu drive program. So this is the tax you can try by yourself. So for the overflow condition, we go for this condition. Then either one is true, then we have to go for the overflow condition means that, for example, this is our queue. This is our queue is given. So this is queue means indexing we are implemented by help of the this queue size that array. So queue means, so this side we called as the front end. This side we called as the rear end. Both the side insertion deletion can be possible because it is a double-ended. So first condition, if the front equal to 0 and rear equal to, so it means that here already 10, 20, 30, 40, 50, 60 means it will front point to this one and rear point to the maximum -1. So this is the case where front equal to 0 and rear equal to -1. Or it can be possible. Condition is underflow. Underflow means if the front value equal to -1, then we say it is a underflow condition. So this is the algorithm for the insert into first front end, back end, deletion, rear. So this is our complete program. As I have already told you that I have already put into the my PPT. So this is from the front is full, is empty. This is our front insert. So here what happened, whenever we go for the insertion in this case, what happened, we have to, this is the case for q equal to empty. So for example, for this case, q is empty, means there is no data is present and we have to insert from this side. This is the front end, this is the rear end. So from this side, we have to insert. If front equal to minus, rear equal to minus means list q is our empty. So first element we have to. So what we have to make? We have to make the, this is the front, this is the rear. So both the point we have to make an index equal to 0. Then we have to store the value, for example, 25. So this is the case for empty q. Next one, if the front equal to 0, then why this making the front equal to 0 means, For example, this is front. This data is already present. For example, 10, 20, 30, here 5 is present and this is the rear position. Here we are implemented by help of a circular queue. So if front equal to 0 means anyhow we have to insert from this side. That's why if it is 0 means this index is point to 0, then what happened? We have to make the front to this side. So front it will move to this side. That is the max minus 1. So front we have to make the max minus 1 because it is a circular queue. This queue can be formed by help of a circular queue. If it is 0 index, so here what happened? This is the max size minus 1. If front point to this one, then what happened? We have to make front to this one and store the data because from front end we have to insert the value. This data is already present. So what we have to make? We have to make front to the max minus 1 and we have to store the value. Otherwise means, for example, this is the case. For example, front point to this one, rear point to this one. Your data 10, 20, 30 is present. Now, what is our question? Insert into the front end. So now what happened? If this is the 0, 1, 2, 3, 4, 5, 6, so on indexing. So now front point to which value? 3 value. So what is our objective? Insert into from the front position. So means here we have to insert. Previously, maybe data is stored, already data is deleted. After deletion, what happened? Front point to this location, that is the 3 location. Now we have to insert into the front position. Means we have to make the front equal to front minus 1. Now you have to front make 0. That's why 3 minus 1 equal to 2. That's why we have to make the front equal to front minus 1. Then we have to store whatever value we want insert. So for insert into the front position, this is the position. This position we have to insert anyhow from the queue. That's why if it is empty, then you have to make the 0 and insert. Otherwise, if it is a 0, you have to make to the max minus 1 because here we are implemented by help of the circular queue concept. So we have to make point to this one and store the data. Otherwise, we have decrement the front pointer value and store the value. This is the case for insert into the front position, the rear position. So what happened? This is our queue. Q. So Q means this is our queue. This is from front end. This is for the rear end. So this is the rear end. This is front end. This is rear end. So here what happened? We have to insert from this. So both the position we can insert, both the position we can delete. Here also insertion can possible, deletion can be possible. Here insertion can be possible because it is a double ended. But if our condition is a insert from the rear side, so means this side we have to insert the data. So what happened if front equal to minus 1, rear equal to minus? Means Q is empty. If the Q is empty means there is no data. Then what happened? This is 0, 1, 2, 3. So if front equal to minus 1 means there is no data present. So we have to make this one as a front because anyhow this side we have to insert. This side means there is no element. So whatever element it will be inserted, it will go to the first position. So you have to insert, make this one as a front, this one as a rear and store the value 5. For example, our value is 5. Else it means, for example, another case. So this side we have to insert. So if rear equal to max minus 1. So means, for example, this is 0, 1, 2, 3, 4. This is max size minus 1 because the last is if the rear point to this one. Means this, for example, 5, 6, 7. Data is already. So this is the end of. So if it is end, there is no space inside the rear. So what happened? We have make the rear points to 0 and we have to store whatever value 10. So this is a simple case of the circular queue. Same here, it is represented in straight line. So if it is a 0, 1, 2, 3, 4, if the rear points to this one, then what happened? Rear should be points to this one. If the rear points to this value, then what happened? It points to this one and we have to store the value. Simple logic. Otherwise, what happened? Otherwise means this is a general case, that is it is a real pointer. For example, 0, 1, 2, 3, 4, 5. Data store 10, 20, 30, 40. Now we have to insert a value at the rear position. So what happened? So we have to increment the rear pointer to this one 3 to 4. then we have to store the value. So this is the simple case, that is the insert at the rear position. Then we have to delete the data. Means deletion also in case of double-ended queue, we can perform by the both the end. Anyhow, first condition we have to check whether it is empty or not. If it is empty, queue is empty, deletion cannot possible. Otherwise, whatever data is present here, what happened? Deletion from the front. So this is the front side, this is the rear side. So whatever data is present inside the front, we have to delete. For example, in this queue, this is a data is present, this is the front, this is the rear. Remaining data is already deleted. Only one element is present. So if front equal to rear, both are the same. After deletion, what happened? We have to make the front point to this one, rear also point to this one, because after that there is no data is present. Previously, data was present. For example, one by one data is present and 40 is present. After insertion, this is the rear. For example, this is the rear data. After that, the deletion done. So front point to this, and after that deletion, after that deletion, then what happened? Finally, this position is stored. So after the this, there is no element. So if there is no element, means the front as well as the rear should be made as a front minus one. Another case, for example, this is the data is present. So 10, 20, 30, 40, 50, so on. For example, this is our boundary of the queue. After that, there is no data is present. So this is 0, 1, 2, 3, 4, 5, 6. So this is the data is present. Now, for example, front point to this one. For example, then what happened? Anyhow, our deletion should be from the front side. This side we want. So now front points to this one, means after deletion front point to this one. So now once we delete the value, after that what happened? There is nothing to be done, as it's a circular, means it should be moved back to this one. After that, this element should be done deleted. That's why it makes the front equal to 0. Otherwise, for example, front point to this one, then we delete this value. Once we delete, means front will be moved to the next location, to be deleted, means this element it will be. So front plus plus, because deletion should be front side, that's why it moves to the next element. If it is a max minus one, it will move to the next, means it is a circular, anyhow it will move to next. So next means circular queue, that's why it's moved to the 0 location. One is the deletion from the rear end. So whenever you go for deletion from rear end, first time you have to check whether queue is empty or not. If queue is empty, means we have to print queue is empty and we cannot perform any deletion. Otherwise, what happened? Here the deletion from the rear side. Rear side means this is the front end side, this is the rear end side. So we have to delete from this side. Previous was from this side, right now this side. So here what happened? If front equal to rear means only one element is present. That is front as well as the rear. Only one element is present, remaining elements are already deleted. If all elements are already deleted and a single element, then what happened? After the deletion, we have to make the queue as a queue. How to make the queue as a queue? If you make the front equal to minus 1, because 1, 2, 3, 4, so on, this is the max size minus 1. So 0 before that means minus 1. That's why we have to make the front as well as the rear equal to minus 1. This is the case. Otherwise, if the front equal to 0, so for example, here what happened? We have to delete from this side. So for example, here equal to 0. So this is the 0 pointer. So if it is a 0 pointer and our objective is delete from this way. So for example, 10 we are deleted, after that 20, here 30, 40, 50 elements are there. Now if rear equal to 0, means we delete the value, then what happened? We have to make the rear point to this side so that the deletion from this side can be possible. After that 20 is deleted, then it will move to the this location. So it is 1, 2, 3, 4, 5. So once remove, it will go to this location. Then once if you go for deletion of 5, then what happened? We have to delete to this side, 4 to 5. Then 4 to 3. That's why else part. It means no condition match. We have to make the rear equal to minus minus. It will related by 1 because we are deleting from rear side. That's why we have to make the minus minus. This is the way we have to pop more complicated. This is for display. Display is the same. This display I have already explained in the circular key. You can go and refer it. So this is our main function. Hope you are able to understand the concept of double-ended queue and how we are implemented by help of a circular array and circular queue. So here this is the case for input restricted. This is the case for output restricted. So thanks for watching the video. Please subscribe the channel, like the channel as well as share the channel. If you have any issue during the concept wise or during the implementation wise, so you can write in comment section. I will definitely try to help you out. Thank you so much.